This video is in tandem with the Biomate video, and it will be published in a hypomnema manual. We're working on the biorhythm, focusing on the days tab, which is where most of our information is generated. To give the end user an idea of what we're doing here, we are generating under the days chart a biorhythm chart reflecting an individual's strengths in the area of their physical well-being, their emotional well-being. If you see here on the top right, physical is graphed by the black line, emotional is graphed by the red line, intellectual is graphed by the blue line. And this is elaborately expressed much more so in the hypomnema. It's a manual that explains more what column K is doing, what column L is doing, and column M in this biorhythm proof. These columns here, K, L, and M, effectively calculating for X, which is used under the sine formula, sine here. And these subsequently are graphed under the days chart. So for instance, this particular individual is high performing around, let's say, June 24th, roughly June 23rd, June 24th, right around this range. Their tops on their physical, their intellectual, and their emotional capabilities within this time range. And to get more technical about the calculations, let's say we are confident in our sine X calculation, and we go to U33001. So I'll do Control G, U33001, just to see what date that is. Oh, and here's something I'd like to bring up, by the way. You notice in Excel this limitation of, and by the way, I need to keep this to D. Let's see if this is D, it is. I need to make an update to the model, I just realized. Because I like for it to pull in from B1 after I change it to Biorhythm D, which gives us a date. So I want to make sure that everything's pulling in from just one updated cell, and that's standard practice to updating a model and making sure that the end user knows what they're doing here. This is a limitation to my model. I really should have just pulled in from B1 and then added subsequent days. So let me show you another limitation I came across. What we're doing is date, and we're pulling in a date, which is the birthday origin of an individual. The individual happens to be me, so I'm born on some day. And from that date, I keep adding a day's worth. So for instance, I'm born on this date, and I keep adding 23rd, 24th, keep going up a day. If you see, I was born in 82. This is nothing to be proud of. I mean, maybe it is, but not in this year, because I'm a little bit older than every day, every minute, we're a little bit older, yeah? But now you know how old I am. So the idea is we're graphing our date of birth, add a day, and then the emotional, the physical and the intellectual strengths of the individual based off of this theory, this biorhythm theory. And as I'm building this out, I noticed, let's see, around here with the date formula, let's see when this starts. I think it starts at like, I think 32,746, or let's just add a hard code number, 32745. We'll do 32746. Just not, it's not increasing anymore. 32747. I could add even like a 32, let's say I add 40,000 days to my date of birth. It just is limited to a maximum of August 16, 2072. So who knows, maybe I still have 50 years, but based on this data with Excel, that's around the time it wants to stop, doesn't want to do anymore. So it will be interesting to see, you know, is my death date going to be 2072 in August? If you really want to test for these things, or is it some sort of a data limitation in Excel? So I'm writing this Hypomnemna. It's a fictional memoir, and I do get a little weird with computer science and different types of beliefs. And if you've seen the biomate representation, these colors are different. So for instance, what they are using in the biomate, and even in this depiction here, emotional and intellectual, the emotional and intellectual lines are different. And to explain a little bit more, we're really dealing with 23 days. As you can see here, C21 is 23 days. This is the physical. 28 days is the emotional cycle of a human. Emotional 28 is pretty easy to remember because that's the cyclicality of the moon. And 23, I guess you could say it's around a woman's period, and you can remember it that way. I'm sorry, I don't mean to be, I'm just trying to think of different mnemonics, different ways of remembering this. So physical is 23 days, cycles, 28 are emotional. This is the moon. You know how with astronomy, astrology, we're always saying the moon, this ebb and tide is the full moon, like werewolves and all this stuff is around the emotions of humans. And our intelligence is 33 days, is the way that this biorhythm theory is measuring the strength of a human being. So here are the calculations. I wanted to verify my numbers are calculating X for sine accordingly, because I'm basically calculating X for sine. And the variance between this trigger C29, if this is true, I'm using M. If not, I'm using S. As you can see in S, I was just multiplying everything by, by 100. So this is multiplied by 100, and this section here is adding a radian. And the reason this is important is because radian does impact the calculation of sine in Excel, and the best way I can demonstrate this is if you take a look at sine and radians of a 45-degree angle, you'll get a result of roughly 70%. Or you could do 45 pi. This is another way of calculating radian to get the same result, this 71. So what was a massive challenge for me is proving that I am using the correct calculation under the days tab and making sure that I'm using this approach here as X instead of this approach here as X, which is effectively double counting radian, and how to back into the numbers, which is what I want to emphasize the most of this proof. Is we can take a look at something like this, like a 45-degree angle. This is the hypotenuse, this is the adjacent, and this is the opposite. So we have angle A, B, and C. And incidentally, this will be published material. Also, it can be used for correlations and time series for stock pricing. In this particular case, we did it for cyclicals of a human biorhythm based on 23, 28, 33 days, and we needed to make sure our triangle is being calculated accurately in Excel so that it would generate these graphs. And you saw on the Biomate, we were able to tie it back to the .NET site. I'm also going to include that particular video. So that's analog to digital, and this is an exterior proof, basically digging into how we're making these calcs, how we're making these calculations. And we are effectively doing pi 180, but in this case, A2 is the time. So instead of doing pi 180 for, and pi being 3.14, a way of calculating a circle, so we're using triangles and circles to graph out time. These triangles and circles fundamentally take us back to A squared, B squared, C squared. And instead of just plugging in, let's say, I needed to prove this, instead of just plugging in sine 45 degrees, or even sometimes a user can be even making a mistake and saying, hey, I'm plugging in sine 0.45. It's about being careful with these particular more complex formulas that don't quite tell you what is number. What is this number? This number actually has to be the radians to be able to tie out this data, and a quick way to back into the information is, for instance, here's the radians calculation, 45 degrees. Here's another way of doing it, which is pi divided by 180. And then if I have a triangle in the adjacent, and I'll show you again what those look like. A triangle in the adjacent line, which is the horizontal line, which is 5 centimeters long, and I divide these 5 centimeters by a 45-degree angle, I ought to be able to get back the length of the hypotenuse. This is a triangle that is 3.8 centimeters in the adjacent. Divide that by the sine of a 45-degree angle. This gives me the hypotenuse, this gives me the hypotenuse, this gives me the hypotenuse. So it provides us with the length of the hypotenuse. And we can back into these numbers by using a calculator. Here again is the information. So we're basically dividing radian 45, or doing pi times divided by 180. And we're doing 1.6 centimeters, that's the adjacent side, divided by 45 degrees, and this gives us the hypotenuse, the length of the hypotenuse, the length of the hypotenuse. And by doing this with let's go back to our chart and look into 7/7. Let's do July 7th, 2020, or one different. So we'll do, just because the blue is the intellectual point sticking out. So we'll do, and we know that's 33 days. So we'll do on 7/13, just to double check the information and how the graphing actually works another way, instead of like, and also the basics, a squared, b squared equals c squared. C squared is the hypotenuse to the power of 1 divided by 2. We ought to be able to back into two equal length sides and the adjacent and the opposite sides. And that's how we know, based on an angle, based on a horizontal line, or based on a side, if our hypotenuse measure is accurate, because the hypotenuse would be equal to c squared, and we would just a squared or b squared the other sides. And since it's a 45-degree angle, both sides, the opposite and the adjacent, are the same. This is, and I've hopefully explained this a little bit better in the manual. If you're interested, I can provide you with this chapter just separately. I'm still working on editing and auditing everything for the hypomnemna for absolute publication. But so here is 7/13. I wanted to show you another way that I can verify the graphing and what the graphing's doing. So 7/13, we are somewhere between negative 0.5, negative 0.5 and negative 100%. So we're saying 70, they're at like, they're not even neutral. They're like 75% below their usual intellectual strength, around 7/14. So let's go under days. Um, 7/14, 2023. And I'll come across here, which is negative. So sine 28/20, which we were saying is pi, the number of days since birth, divided by 23. C23, which is 33 days, will give us, where are we at? 14.8. Trilogy. Let's go to C23 for the intellectual. So you can see this is 33 days. 148, 14. So 14,814. It is negative 54,064. And the value is we're doing 14. Here's 13. The value on y is negative 69,007. So 7/13, 2023, value is negative 69. This is 0.690079. Going back to my days, 690079, because we had stopped on, okay, I guess we're doing 14. Let's do 7/14. So this is the 79008. That's on the y-axis. And the 14 going on up. 54,064, again, we'll go under days. -54 and 0.64. But it still needs 1481 days. This chart is counting that many days past my origin date, my birthday. And then this graph just gets bound like that over time. It's bound with 23, 28, and 33 days, and we're basically creating a circle. And that's how we have our +1 and our -1 bounds. And again, what I wanted to emphasize, because I was trying to verify that these x's, or rather, I should be using the calculations in K, L, and M rather than the calculations in Q, R, and S, or again use radian, which Excel needs. So for an angle, if I'm using an angle, I have to use the radian in Excel, or in a calculator we could use, so for instance for Texas, I think just sine, you plug in 45 and sine. Here, so 45 degrees, not even 0.45, you need 45 seconds, and then sine, and this will produce the hypotenuse, this 0.70 measure. And the thing is, this 0.70 measure is then what I used back into what might be the hypotenuse. But if you notice the difference, so when I was trying to rationalize it to myself, one is like an adjacent and a hypotenuse. So I can use this a squared, b squared, c squared scenario. I come back into using this radian scenario. And then I had to try to convert it back to, this is the x and the y axis, because we know this one is a length and the other one is a straight up, this is the y axis. So I needed some sort of a justification. I'm bound, which is reasonable. I'm able to tie it back to the biome. I'm able to tie it back to the .NET site. I hope this is a decent enough explanation where somebody else can take a look at this and be like, pairwise, this is making sense to me. Especially if I can subsequently start using this for stock price movements and correlations. So I hope this is revealing to you. There's more thorough ABC step-by-step ways of calculating it, and this proof is available for anyone that might want to use it and build upon it. This is Jasmine. It's a supplemental to the Hypermnemna fictional memoir that will be published in 2024. Thanks, and I'll catch you on the next one.